We have one rotating disc of diameter equal to what? 1 meter. Two eccentric masses of 0.5 kg at radii equal to 50, and another one is 50 mm at an angular position of 0 and 150. So are these two masses are mass? 1 meter as well. So we have one mass equals to what? 0.5 at what radius? 50. And we have second mass also 0.5 and it is equals to what? 60. What is their angular position? 0 and 150. He says that a balancing mass of 0.1 kg is to be used to balance the rotor. What is the radial position of that balancing mass? This figure. Let this one is mass m1 of mass equals to 0.5 kg and the corresponding radius is r1 equals to 50 mm. Will not change the unit. So this one is same as r1 and this one is same as m1, and this is my x-axis, positive x-axis rather. And what is the angle of theta 1? So is theta 1 is 0. To show correct on this diagram. Then we have second mass equals to what? m2. Mass m2 is also equals to what? 0.5 kg. But this mass is situated at radius equals to what? 60. This mass I am showing at this point. So this one is m2. This one is theta 2. If the angle theta 2 is given to us is 150 degree. And is your job to balance these both masses by single mass. And naturally you don't want to have any type of couple. So you have balance this mass somewhere here. So let's say this distance equals to what? RB, and this mass equals to what? MB. Now I don't know the angle of this one, but I have a space available at this point, so I will show my mass here so that my figure is clear. This has no meaning actually. So this one is MB and this one is RB. But is RB is known or MB is known? MB is known to me. So MB1 is what? 0.1 kg. And what I don't know is this position. That is angle theta B, I don't know. So right now in my figure, how many unknowns I have? One unknown is RB and one unknown is theta B. It means that I must have two equations. There is no question of moment. So is my sigma fx is sufficient and sigma fy is sufficient. So we'll only go for two forces. One is sigma fx and one is sigma fy. Let me check. Sigma fx, right, what is positive. Sign convention will not follow because we are using the positive x-axis. First component is m1 r1 cos theta 1, m2 r2 cos theta 2, mb1 rb1 cos theta b1. Substitute all value and try to find out rb1 cos theta b1. So this answer come out to be 9.81 and this is positive answer. So make this one is rightward arrow. Follow sign convention. Next is sigma fy, vertically upward positive, must equal to 0. All these terms will be replaced by sign term, that's all. So substitute all these value and find out the value of RB1 into sine of theta B1. Your answer come out to be minus 150, but always write your positive answer. So this one is 150. Where is next? Is it downward? So show this force downward. So you first construct this vector that is going to the right. So this is the approximate vector will be like this. On the tip of this one, you construct second vector. That is called as vector diagram. And then close this. Equals to what? Is it 9.81? This one is 9.81 to what? 150. And is this angle is therefore theta B1. Because if you take tan, this divided by this one, is it tan of theta B1. So this one is tan of theta B1. Opposite upon adjacent is 150 divided by 9.81. Solve this one. That is theta B1. Either in this equation or in this equation. And solve for RB1 and confirm what is RB1. The final answer is 151.6. But remember here, your x-axis is this way. So if you have to give the answer of this one, your answer will be this one. All angles are measured with what? Positive x-axis. So what is the angle at which you have to attach this mass will be equals to what? 360 minus of 86.29. So your angle with respect to x is 273.2. And is all the masses are in the same plane. They are in the same plane. Masses are given, their dimensions are, radius are given, and their angular positions are also given. And if you read the problem, and you can see the line of the angular position of the masses B, C, D are 60, 135 from mass A. We have to fix up mass A first. So let me fix up mass here at 0 angle. Then I am very convenient to show other masses. So let me fix up this one. Let's call this one is A. So what is theta A? What is MA? MA is 12. Now what is the angle between B and A? 60. So 60 we will show somewhere here. What is the mass of B? 10. What is the radius of A? 40. What is this angle? And what is the radius of B? 50. Then third mass is attached at what angle? 135. With respect to what? A. So that will come in this quadrant. This angle is theta C. What is the mass C? 18 kg. Radius it is attached. 60. And what is the value of theta C? 135. And do you have one more mass? That is what? 270. Is the 270 exactly here? This one is mass D. What is of this mass? 15 kg. What radius? At 30 mm. And what is this angular distance? 270. He is interested what? Find the magnitude and position of the balancing mass at radius equal to what? 100. So we don't know where is that, but I have a space here. So right now I will show you this mass. Even I don't know what is this total angle equals to what? Theta B. That is another unknown for me. But if the radius is known to me, radius equals to what? 100. And is this problem is a single plane problem, so only sigma f is sufficient. And it means that sigma fx must equal to what? 0. I will write this term, okay? You just take me. I will write this mi ri cos of I. This is fine? Now I will directly make entry of this one by one. We'll start with MA. MA equals to what? 12. Distance equals to what? 40. Angle equals to what? 0. Next term. Mass equals to what? 10. Radius equals to what? 50. Angle equals to what? 60. Plus. Next mass. 80. Radius equal to what? 60. Angle equals to what? 135. Plus D mass. Mass equals to what? 15. Radius equals to what? 30. Angle equals to what? Cos of 270. And one is balancing mass. MB. Radius is known 100. Angle is what? Cos of theta B. Find out the product MB multiplied by cos of theta B. Your answer is positive. Okay, the answer is 0.34. Is it positive? So assumption is correct. Okay, now we'll go for sigma Fi. So sigma Fy is equal to sum of Mi, Ri and sine of theta, equations in terms of sine, and find out value of Mb multiplied by sine of theta b. Answer is come out to be minus 7.4. More precisely 7.47. But this answer is negative. So this answer is, you have to make it positive, and we are in the y direction. Negative of y is this way. First use x vector. So x is going this way and y is going for the tip in downward direction. So if you join this, you will get your resultant vector. This angle is theta b. This value is cos term is 0.34 and this value is 7.47. So you can take tan theta. Is this value is 360 minus 87.4. So actually this should not be theta b. Theta b is this one. कितना रहा? 270.6. Okay, now you plug in this value. That is the correct answer of theta b, because theta b we are shown with respect to x-axis. So we can say this is just a theta. This value in either of this equation and check you are getting both sign conventions are correct. What is the value of MB from this? 7.46 kg. Now what if we assume, is it correct now? But this is sheer coincidence.